Okay, in this section we're going to be going through 4D, or sorry, not 4D, 3D, which is going to be vertical forces. So again, there's a bunch of new stuff in this section, but it's all really based on what you saw in the first time when you saw the second law. So again, free body diagrams, you've seen those before, and Newton's second law. You've seen them in the horizontal direction primarily. You've seen them being applied to horizontal forces, but they can also be applied to forces acting on objects in the vertical direction. So same thing, just as you saw it work in the horizontal direction, it's going to work fine in the vertical direction as well. So the important thing to keep in mind with that is because it can be used in multiple directions, it's only going to be, you have to be careful because it's only going to be valid if you look at one dimension at once. So that basically means if you're going to look at vertical forces, just look at vertical forces. If you look at horizontal forces, just look at horizontal forces. So for example, I'll do it out with this free body diagram right here. So if you wanted to look at the vertical net force, you would just look at the forces that go up and down. So the vertical net force, just the forces that go up and down. So we'd have, what do we have? We have Fn in this picture, and I'll get into what that is in a minute, but that's acting up, so it's positive, and then we're going to add the other force, Fg, the force of gravity, and that would be negative because it's down. Get that a little neater. Fg because it's negative because it's down is equal to ma. So again, if we wanted to analyze the forces in the vertical direction, we could do that, but we just got to be careful that we're only looking at the vertical forces. Or, same idea, we can look at the horizontal forces, right? All the forces acting in the x direction or the horizontal direction, but we have to be careful we're only getting the horizontal forces. So in this free body diagram right here, the net force in the x direction is really just Fa, and that's going to be equal to mass times acceleration. So just keep that in mind. The net force, you add the forces the same in either, set of directions, but just make sure you're only looking at the vertical or the horizontal. You're not mixing the two. So the next thing is there's some forces that are going to be primarily acting in the vertical direction. We're going to go through those. So the first one is the gravitational force, Fg. Gravitational force, Fg. That's the force that gravity pulls down an object, right? You've already seen this. If you have something sitting on a planet, there's going to be some force of gravity pulling down on it, pulling it towards the planet. So that's the gravitational force. And then there's this new force. It's called the normal force. Normal. And it has the symbol F with the subscript n, and that's the force on a surface on an object. So what that means is basically surfaces will actually have a force that acts if if they're pushed. For example, if there's a wall and you push on the wall, right? If you push on the wall, you're going to get a normal force actually back from that surface, from the wall. That's called the normal force. Same thing, if you put a book on a table, there's going to be a normal force from the table that pushes that book back up. So it's important to keep in mind that the normal force is the force from a surface of an object, or from a force of a surface on an object. So, you put an object on a surface, there'll be some force because of that. Unless it's falling through it, you're going to have a normal force. And the last thing to keep in mind is this is a situation that comes up a lot. So you're going to be seeing objects that are sitting on the ground, and the force of gravity is going to pull them down if they're on a planet like Earth, right? They're going to get pulled downward by gravity. And then that's typically going to be balanced by the normal force that pushes up from that surface. Pushing up. So again, that's a common scenario. So if you have an object and it's just sitting on the ground, unless it's falling through the ground, the force of gravity is being balanced by the normal force. So keep that in mind. If you just have an object sitting, it's not moving in the vertical direction at all, again, you're going to have that pair of forces acting. So that's really it for the notes. It's important to just keep in mind how we apply net force in the vertical direction. There's a couple forces that are primarily in the vertical direction, and this scenario kind of right here of an object sitting on a surface. So that's all the information. Let's see a problem. There we go. So see if you could solve it first before I go through it. Even if you can just solve it partially, even if you just have the free body diagram or just your knowns and unknowns, that's definitely helpful than having, nothing. Okay, I'll go through it. So we have a VHS tape of Back to the Future, great movie. We know that its mass is 100 grams and it's sitting on a kitchen table. It's saying if you push down on it with a force of 8 newtons, what is the normal force? Normal force. So there's a fair bit going on, but it's not that bad if we careful with our writing out everything first. So let's write out the situation. We have a object and it's sitting on a surface. I'll draw the surface. So we have a normal force, or I'll draw the other force first. So if it's sitting on a surface, assuming this is on Earth, there's a force of gravity pulling it down. And if you're pushing down on it, there's also an applied force down as well. So there's two forces, the force of gravity and the applied force that you're pushing down on it with. The other force is the normal force, and that's going to be pushing it up. And that's from the table. So there's two forces that are pulling it down or pushing it down, the gravity, the applied force. Then there's a normal force from the table. If there wasn't a normal force from the table, it would be falling through the table. So that needs to be there. Let's see what else. We know the mass is 100 grams or 0.1 kilograms. We know that the applied force is given as 8 newtons. And we know we're looking for Fn. The next thing would be, if we're looking to figure out a force, and we know something about forces, it's probably the second law in the vertical direction, the y direction. It's going to equal m times a. So let's write out all of the forces for the net force. Let's write out all the forces present. What do we got? Fn plus negative Fg plus negative Fa, and those two forces are negative because they're down. It's equal to Ma. Let's think about what we know. We know we don't know Fg. We're looking for Fn. We know Fa. We know the mass. If we think about the acceleration, let's think about what's happening. It's sitting on a table. So if it's sitting on a table, it's not moving. It's being pushed, but it's not moving. It's not falling through the table. It's not flying into the air. So if an object is not moving like this, there's no acceleration because there's no change in velocity. So it's a little bit tricky, but if you think about it, we can know the acceleration. We can know that it's 0. And now let's think about the force of gravity. So the force of gravity, we can actually calculate that because the force of gravity is equal to m times little g. Again, we're assuming this is on Earth. So m times little g, so the force of gravity is going to be the mass, 0.1, times 9.8 little g. It's going to be 0.98 newtons is the force of gravity. So now we know the force of gravity, the applied force, the mass, the acceleration, and we can solve for Fn. So before I do the last algebra steps, keep in mind that it looks like there's a lot going on here, and there's a lot of stuff, but it all goes back to, did you draw a free body diagram? Did you write out your knowns? Did you write out your unknown? Did you find an equation that makes sense, that seems to relate, the things you want to each other? So again, just keep that in mind before I finish solving it, that it looks like a lot going on, but it's all based on, are you writing everything out? Maybe the last step is see if you can solve it from here before I do the algebra out. So see if you can just plug everything in, just solve it if you were not able to get to here. If you were, that's good. And I will continue. So please try to solve it out if you were not quite able to get it. Just plugging in and solving. So I'll do that now. So we have Fn is plus the force of gravity. It's negative 0.98. There we go. Parentheses. Plus negative 8 Fa. And then this side is just going to be 0.1 times A is 0. So we get what? Fn plus, what is it? It's negative 9.98 plus negative 8. So that's Fn minus 8.98, and the right side is just going to be 0. So we get the normal force is equal to 8.98 newtons. Seems to make sense. It's going up, and the normal force is going up. So that's the answer. Again, little bit of algebra, a lot of just setup, a lot of just writing out what you know and do not know. Okay, so make sure you have the problem solution down. Make sure you have all the blanks filled in for the notes, and that's it for now.